Today, I'm here to represent Menlo Security as a product marketer and evangelist on the topic of understanding how zero trust principles can work with internet isolation, a service we can provide for every endpoint in your ecosystem. The success of our cloud proxy and isolation platform have allowed us to partner with 8 of the 10 largest global banks and be designated visionary by Gartner in their Magic Quadrant for secure web gateways. Now, the concept of zero trust holds that no actor, whether in or outside the network, should be trusted to access information by default. And the industry has responded predictably by building more and more locks to manage access more securely. Now, the idea of zero trust came from the deficiencies of traditional architecture. Users at the bottom level, the remote worker, main and regional offices, connect to the internet through web and email gateways, which use firewalls as the cornerstone to the network. But the problems of traditional architecture were the lack of internal checks on data access and usage, everyone had to be under the same roof, and firewalls became a single point of failure. And because of these problems, unfortunately, the traditional model of security completely falls apart in the modern world, where people are connecting into the network from anywhere and not protected by the main firewall. Suddenly, any user and any device could become a vector for attack. It's the massive security problem that traditional architecture could not solve. Zero Trust then steps in to provide 5 core principles that work together to build a more secure future. 1. The network is always assumed to be dangerous. 2. Threats can be inside or outside the network. 3. Actors inside the network are not automatically trusted. 4. Authenticate and authorize every device, user, and network flow. And 5. Security policies must be dynamic and use multiple streams of data. Now, principles 2, 3, and 4 often apply to the concepts of identity and access management. Concept 5 could apply to technologies like APIs and security information and event management. But at Menlo, we are concerned most with the first principle, and solving for that principle means confronting the portal through which most dangers emerge, the browser. And there is a well-known solution to the problem: containers used for remote browser isolation. Remote browsers allow you to access the internet safely by opening containers in a virtual cloud environment away from the network, hence the term internet isolation. Now, here's the key. If you can prevent threats at the source by being able to stop people from entering their credentials into a phishing website, you'd make your network vastly more secure. At Menlo Security, we believe internet isolation addresses the security concerns of Zero Trust Principle 1, that the network is always assumed to be dangerous. Now, let's take a moment to review internet isolation in depth. We'll start by comparing the typical browsing experience to the more secure, isolated version. Traditional architecture is far too trusting. Over the years, a lot of energy has been put into identity and access management. But the issue is, once access has been granted, all bets are off. That's why phishing attacks are particularly dangerous. Phishing sites are successful because people are tricked into handing over their credentials so that criminals can access their network. But first, a quick review of how internet isolation works. In the typical scenario, a worker would access the internet through a browser, and the browser would then make a request, which is fulfilled by the receiving server, and then the information returns back to the end device. This is the fetch part. The web code is then run on the local machine. This is the execute part, and the machine then builds the web page for the user. This is rendering. Now, the most dangerous part of the process is the execute stage, because malware often comes in the form of active content. A better solution is to strip out all of that active content using internet isolation. Isolation works by using the cloud to rewrite all web code traveling to the device. Content is then safely rendered on the end device. Importantly, the most risky parts of browsing, the fetch and execute portions, are all done in the cloud. Internet isolation provides a safety net for when users are distracted and vulnerable to phishing. Now, based on how you implement your isolation security policy, with isolation, phishing sites can be placed into a read-only mode to stop credential theft. This is done by identifying phishing sites with a risk score. Importantly, users from across the world are able to have the same high level of protection, and when implemented effectively and efficiently, is done without lag. Let's take a look at how read-only mode, using internet isolation, protects against phishing by preventing users from entering their credentials into fake websites. But first, a brief review of the commonality of ransomware. According to a study by CyberEdge, 62% of all surveyed companies were targeted by criminals using ransomware in the last year. Now, 58% of those companies paid the criminal, and 33% of the people who paid the criminal never recovered their lost data. And importantly, over 90% of these attacks arise from phishing, often delivered through email. Using email gateways as an example, phishing succeeds by taking advantage of the time it takes for an email filter to categorize email links. Detection of malicious websites is slow. According to our research, web and email filters misidentify 10 to 15% of phishing sites as safe when they're accessed by the end user. If those sites are accessed through email, IT admins may allow, block, or filter, but often they have inadequate policies to protect against the danger of these risky links. And as we know, roughly around 5,000 to 8,000 new phishing sites are created every single day, and there's simply no way possible for IT teams to be able to meet that demand. Basically, the network can't determine the good versus the bad quickly enough. And if they do have isolation, poor implementation generally restricts its use case to just VIPs. Now let's take a moment to walk through the high-level actions at play in an isolated environment. The user clicks on a link which leads to a random site. But because the site isn't trusted or allowed by a policy, we place it into isolation. And finally, when the site is isolated, we deactivate form inputs to prevent users from entering their credentials into phishing websites. This is read-only mode. Direct site input is prohibited while still allowing for basic site interactions that do not risk credential theft. This allows you to apply isolation much more broadly than traditional allow and block designations. And now we have the Menlo Dashboard. Our theme today is granularity and scope. The graphs are movable and allow you to travel backward up to 30 days to view the attacks encountered by your network. Now let's look at all the threats that have been visible and prevented by Menlo Security during that time frame. To read our pie graphs, start to where the noon hour hand would be and read clockwise. Flash, uncategorized sites, risky files, and phishing. Now, a Verizon study found that phishing accounts for 92% of attacks globally. So let's click on phishing to get a good idea of the types of attacks prevented by our system. And drilling down, we can see every prevented phishing attempt on the network in the last 30 days. Once a request is logged, you can then see the attempt by user. Now for a single user, let's drill down to the spreadsheet log. To the right, you see the Edit button. And this allows us to set policy by domain, threat type, user agent, browser, and more. Let's set this domain to isolate and read-only. Save, and then publish. For users interested in granular access control for every network user, Menlo Security provides the management tools you need to secure your system. And something that I would like to point out is that all of this is done from the Logs panel. Now that we've learned to drill down, let's zoom out to the main page dashboard to talk about scope. On the overview page, we can see the top navigation panel that hits at many of our cloud proxy features that are shared across the ecosystem. Specifically, the dashboard tabs of threat, traffic, and bandwidth analysis are related to our cloud proxy. The email analysis and traffic tabs are related to secure G Suite and secure Office 365 products. DLP analysis relates to our DLP product. To the left, we have our side panel. The product tabs on the side panel are Web, Email, and DLP Policy. Logs, insights, and reporting are very useful to understand the health of your system. Let's go to the logs real quick. And as a reminder, we earlier went here to modify some of our user settings. The Insights tab is where you build SQL-like queries that you can use for reporting. This one is done weekly. And to view those reports, we go to Reporting and Risk Report, where we can download or see it in HTML. Now, returning to the idea of scope, let's head to Web Policy and imagine a world where we'd like to protect our users by applying policies that limit their exposure to web-based threats. Now, let's say we want to protect against a category of BitTorrent and peer-to-peer sites because they've been known to be vectors of malware and credential phishing. With Menlo, we help you block the site outright. Or, with Secure Internet, you have the ability and the option to isolate and place the site into read-only mode. Let's go down to the sites that we want to restrict, and we are looking for peer-to-peer sites. Here we go. Currently, they are allowed. Let's go ahead and not block them outright, but select Isolate and Read Only. Save changes. And finally, publish. That's it. We've created a policy for all users that places peer-to-peer sites into isolation's read-only mode. The ability to deploy a feature is something every cloud proxy has, but the ability to deploy a feature as protective as cloud-based isolation is a game changer. But this also extends to web apps. Are users' browsers out of date? Well, you have the option to block them. You can add new exceptions to the rule based on the type of traffic. For example, we want to make sure that our Zendesk traffic, Mozilla, or other files that we know we can trust are allowed to pass through. Starting to get an assault of booby-trapped spreadsheets, we head to Docs and Files. The same type of policy and rules can apply to engineering docs, presentation docs, and docs with extensions that have specific productivity needs, for example, with MS Project or Microsoft OneNote. And the important thing to remember about this is scope. The breadth of the protective services and our global scope makes us an excellent choice for every company. We skipped over how to point the browser to our proxy, so we'll go ahead and cover that now. We'll set up two browsers. The one to the left is our Chrome browser. That is directly connecting to the internet. And the one to the right is our browser in orange that's going through our Menlo cloud. To set up the proxy, what we'll want to do is get the proxy address. This is the internet address that is the location of the proxy in the cloud. For here, I have one already loaded. But if you would like to find it in the dashboard, you can go to Settings, Proxy Auto Config. And in this case, we are using the standard definition that's located right here. Go to Network Settings. It's currently set to not proxy. Let's go ahead and set it to automatically go to our proxy servers here, and then click OK. And that's it. We have now isolated the browser to the right in orange And to the left, this is an unisolated browser. So what this allows us to do is to show you back to back what happens when we go to the different pages. The Office 365 site is to the left, and the phishing site is to the right. At the bottom, we see that Menlo Security has already placed the site into read-only mode. Read-only mode prevents users from entering their credentials and falling prey to phishing. Now let's head back to finish the presentation. At Menlo Security, we believe that this is a superior solution when compared to identity and access management alone. And here's a real-world example of some internet isolation benefits when seen through the lens of zero trust. In this study, our financial services client experienced a 90% reduction in their attack surface and a 261% three-year return on investment. Internet isolation gave them the privilege to concentrate only on the most value-producing security work. To end, we wanted to give you the opportunity to try Menlo at home. That's right, try isolation from the very computer that you are sitting at right now. To get started, head to the link above to see exactly how internet isolation with Menlo Security can work to protect your network environment. We also offer a free 90-day license to get started. And lastly, you may wish to reach out to us by email at ask@menlosecurity.com to get the conversation started on how internet isolation can best be deployed in your environment. Now with that, thank you very much for listening to this presentation. My name is James Locus. I'm with Menlo Security, and thank you so much for giving us the opportunity to present our pioneering technology to yourselves. Have a great day and stay healthy.